This lesson is 11.2, and before you listen to this video, I want you to be sure that you have printed off 11.2 Zeros of Polynomial Functions Theorem and Definition Sheet. I emailed that to you, so if you haven't done that, do it before you watch this video. The other thing that you need to print off is 11.2 handout. It's going to look like this, and it's saved as 11.2 handout, 11.2 homework, page 1. So it's going to have a HW on it somewhere. I think this is going to be our easiest way for me to help you with 11.2. It's kind of a long section. Let's look over these theorems and definitions. Factor theorem. The polynomial x minus k is a factor of f of x if and only if f of k equals 0. Example, x minus 2 is a factor of x squared minus 5x plus 6 because whenever I substitute 2 into this function, I get 0 for an answer. So that tells me that x minus 2 is a factor of this. It tells me that 2 is a solution of this. Reminder, before we finish talking about this lesson, you're going to need to remember that conjugates always occur in pairs. If 3 minus I is an answer to an equation, 3 plus I is also. Rational zeros theorem. For any rational zeros, P over Q of a polynomial, P will be a factor of the constant and Q will be a factor of the leading coefficient. This one, you will have to talk about it. It's kind of new to you, and we'll have to talk about it when we get to that part of the lesson. The degree of a polynomial tells how many zeros it has. You've been knowing that. If it's a third degree equation, it's going to have 3 answers. If it's a fourth degree equation, it's going to have 4 answers. Remember, some of the zeros may not be real. The real ones are shown by where the graph crosses the x-axis. Note, zeros, solutions, answers, and x-intercepts are all the same. So these all mean the same. If they're asking you to find a solution and you can look at a graph and find where it crosses the x-axis, then you know the solution. If they're asking you to find a zero and you can see where it crosses the x-axis, then you know the zeros. Okay. The handout looks like this. Since this typing is kind of small, I'm going to rewrite these problems as we go so that we can see them a little better as we're working. The instructions say use the factor theorem to decide whether the second polynomial is a factor of the first. Hint, use substitution with the opposite of the constant in the binomial. So on all of these, I've given you, this is to help you with homework problem 1 through 3. These are your little instructions. So that just means take this 4, substitute it in place of x, put this in your calculator. Whenever you do that, if you get 0, then that tells you that x minus 4 is a factor of this. Whenever you substitute 4 into this, you're definitely not going to get 0. I can tell by looking. So this one is a no. Let's do a 2a. F of x equals x squared minus 5x plus 6. I want to know if x minus 3 is a factor of this. So I'm going to go 3 squared minus 5 times 3 plus 6. That is 9, plus 6 is 15. 15 minus 15 is 0. Therefore, yes, x minus 3 is a factor of x squared minus 5x plus 6. Second section. Factor f of x into linear factors given that k is a 0. So they're telling me that's one of my answers. they want me to factor this. So they're telling me that this is one of my answers, and they want me to factor this. We're going to do everything that we do with the simplest form possible, the way that takes the least effort. So we're going to use synthetic division. We're going to divide 2 into this function. 2, negative 3, negative 17, 30. We have 2, 4, 1, 2, negative 15, negative 30. We have a reduced equation of 2x squared plus x minus 15. They want me to factor this. So I already know if k is 2 that one of my factors is going to be x minus 2. Whenever I factor this, I will be finished with what they're asking me to do. Remember that we multiply first times last. We're looking for numbers that multiply to give us negative 30 and combine to give us 1. 2x squared plus 6x minus 5x minus 15. Take out 2x, you have x plus 3. Take out negative 5, you've got x plus 3. The final answer is x minus 2 times 2x minus 5 times x plus 3. Everybody caught up? Let's put this in our calculator. I want you to put this function in your calculator. Two x cubed minus 3x squared minus 17x plus 30 graph. And guess what? We can see by looking that this crosses at negative 3. We knew that x plus 3 was one of our factors. We can see that this crosses at 2. We knew that 2 was one of our factors. And then crosses somewhere between 2 and 3, and that's that one. So if we were to set each of these equal to 0, we would get these answers: 2, 2.5, negative 3. And we can tell by looking that those are the places where this crosses the x-axis. Problems 5 through 11. For each polynomial, 1 0 is given. Find all others. The instructions say, try the calculator. If that doesn't work, do synthetic division and then the quadratic formula. So they want me to solve this. So they're saying find all the zeros. That just means solve. Well, I want to try using my calculator. If I can look at that calculator and find the places where this crosses the x-axis, then I got my solutions. I know it's going to cross at 3 because they're telling me 3 is one of my answers. So let's put this in the calculator. X cubed minus x squared minus 4x minus 6 graph. The only one that I see is 3. I know that this has 3 answers. This little loop right here doesn't go all the way up there to the x-axis. That's where those 2 imaginary answers are. So since it doesn't cross the x-axis, except for one place, it only has one real answer, and I'm going to have to use the quadratic formula to find those other 2. So I want to do synthetic division and then quadratic formula. So do this on a little piece of paper that's bigger for you. we have 3, 1 and negative 1 and negative 4 and negative 6. I got 1 and 3 and 2 and 6 and 2 and 6. My reduced equation is x squared plus 2x plus 2. Whenever I do the quadratic formula, I'm going to come out with negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2 all over 2. Negative 2 plus or minus the square root of negative 4 over 2. Negative 2 plus or minus 2i all over 2. Negative 1 plus or minus I are those other two answers.